Geometry students, you are going to benefit from a long Algebra 2 video because you will have a short geometry video. So that makes it a little bit easier on the kids who are tracking 2 classes. We've talked about proportions and how do you solve them. We've talked about similar polygons and how do you use similarity statements to solve geometry questions or interesting geometry questions. Now we're going to talk about how do you get triangles specifically to be similar. Well, we have a postulate that says if 2 angles are similar, then the 2 triangles are similar. If 2 angles are congruent. So if we look at that, one thing that you could say here is because these 2 angles are congruent to these 2 angles of a triangle, we know the third angles are congruent. That's why we really only need to get 2 angles congruent. And then if we know the 2 angles are congruent, then we can say those 2 triangles are similar. The ratio may be 1 to 1, which we will then later say that means they are congruent triangles, or the ratio may be 2 to 1 or 2 to 3 or who knows. But doesn't matter what the ratio is. We do know if 2 angles are congruent of one triangle to 2 angles in another triangle, then those triangles are similar. The other theorems we have for proving triangles similar is the side-side-side similarity. So if we go back to this, the way I abbreviate this in proofs is I write AA similarity. That's the reason. Here I'm going to write SSS similarity, and I'm going to use that similarity symbol when I write SSS, especially to distinguish between SSS, which means the 2 triangles are congruent, and SSS inequality, which means 2 sides of a triangle are congruent to 2 sides of another, and we know that the relationship in size between the third side. Chapter 4, Chapter 5, Chapter 6. Okay, so this says if you know AB is similar to RS, the ratio of AB is to RS is the same as the ratio of BC to ST, is the same as the ratio of CA to TR, then you can say the triangles are congruent. What's really important is that the smallest side of one triangle will correspond to the smallest side of another triangle. The medium side of one triangle will correspond to the medium side of the other, and the large side will correspond to the large side of the other. And you probably know where this is going. The next one we get is side-angle-side similarity. And again, the abbreviation, side-angle-side similarity. So, looking at this, what's important is that the angle that you know is congruent is between the 2 sides that you know are in the same ratio. So ZX is to PM what XY is to MN. All right, so those 3 ideas, 2 theorems and 1 postulate, those ways of showing triangles are similar is what you're going to be practicing in class tomorrow. And what you're going to be practicing is answering, here's a little summary, sorry. So what you're going to be practicing is, are these 2 triangles similar, yes or no? Or what would these sides need to be to make them similar? So let's take a look at some examples. Are there similar triangles here? Well, in the first problem, this angle here is 52 and this angle here is 52. And what most kids forget to see is that both triangles have the same angle A. So you've got a 52 down here and a 52 here, and this is A, and this is B, and this is E, and this is A, and this is C, and this is D. So do you see there's this little triangle, but then there's the big triangle. And angle A is congruent to angle A, right? You could see in a proof, reflexive, angle A congruent to angle A. So yes, these are similar. What kids will do, though, is they'll say AB over BC equals EB over DC, and that is completely false. AB to BC is not the same as this whole side to this whole side. You can say that AB to AC, this small side to this whole side, is the same ratio as EB to DC. I love this problem. If this is 32 and this is 58, 32 plus 58 is 90. That means this angle is 90, which means we actually have three similar triangles here. So take a look at this. You've got this triangle here with letter D being the right angle and C being here at 32 and E being here at 58. And then you have this triangle. I'm going to try to draw it in the same way. This is 32 and this is a right angle. So C is where 32 is, F is where that is, and that means this is a D. So that's this triangle, CFD. And then the last triangle looks like this. This is 58 and this is a right angle. This is F and this is E. So that's D. I mean, look at that. In a right triangle, if you drop what's called an altitude, you create three similar triangles. How crazy is that? That's probably an important picture that I would write down if I were you. You might see that again on a test, just saying. And then this one here, we've got vertical angles and then we have parallel lines. So we have this. Remember, alternate interior angles. So it would be triangle SVR is similar to triangle UVT. So notice SV is the same is proportional to UV, VT is proportional to VR, and SR is proportional to UT. And notice how the letters go in that order. Another problem you might see is something like these are three different problems. So the three problems look like this. 1, 2, 3. Are there any similar triangles here? Smallest side, 8 to smallest side, 6. Is that equal to largest side, 16 to largest side, 12? Is that equal to medium size, 12 over medium size 9? That's a question. Are these all the same ratio? Well, the first ratio reduces to 4 over 3. The next ratio reduces to 4 over 3. And the last ratio reduces to 4 over 3. So yes, these two triangles are similar. All right, well, I could check over here. AB, smallest side to smallest side, 8. Largest side to largest side, 16 to 16. Middle side to middle side, this is 1. We'll use a different color, sorry. This is 1. Is this the same as this, which is 1, which is this the same as 1.2? And the answer is no. So ABC is not similar to JHG. And I didn't do that in the right order. ABC is not similar to GHJ. And because these two triangles are similar, I know these two triangles aren't similar as well. Because if ABC is similar to DEF, and it's not similar to that, then DEF would not be similar to GHJ. What about these triangles here? Are they similar? So you do the same thing. 20 to 30, that's 2 to 3, is 24. Or sorry, I did this wrong. I make mistakes. Is smallest side 20 to smallest side 24. Is that the same ratio as middle side 24 to middle side 30? And is that the same ratio as largest side 26 to largest side 33? So 20 over 24, I see 5 over 6. 24 over 30, I see, what is that? Divide both sides by 3. 8 over 10, which is 4 over 5. Is that right? Yeah, divide by 6 and 6. So I can stop right now and say these aren't similar. I can then look at these here. Smallest side 24 to smallest side 30. largest side 33 to largest side 39. And then lastly, middle side 30 to middle side 36. I check those out. That's 4 over 5 using a different color here. So that's 4 over 5. Dividing by 3 here, 11 over 13. Dividing by 3 here, 10 over 12, which is 5 over 6. Okay, so that doesn't seem to work. And then I'm going to have to clear all this out to have some more room. We'll check the last one. And then checking the last one, 20 is to 30. What 24 is to 36. What 26 is to 39. So let's see what happens there. This is 2 to 3. This is divided by 12, 2 to 3. This is, sorry, I should be using a different color so we're not getting confused, 2 to 3. And then 26 over 13, or sorry, over 39 divided by 13, this is 2 to 3. So LMN is similar, and look at how I named that, LMN. So smallest medium. So LMN YZX. Good? And then last but not least, we know vertical angles are congruent. 9 is to 15. What 18 is to 30. Divide by 3, and I get 3 is to 5. Divide by 6, what 3 is to 5. So yes, these are similar. So here I use side angle side similarity. Here I use side 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 similarity. Up here I used, for these two, side 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 similarity. And here I use this one to this one. All right, that's it. Hope you're doing well. Have a good night. Peace.